Okay, now that we have looked at perpendicular bisectors, we're going to look at them more specifically in terms of in a triangle. So, there's a few vocab words here again. We're dealing with what's called concurrent lines, and our concurrent line that we're starting with are the perpendicular bisectors. When we form the perpendicular bisectors within a triangle, we get a point of concurrency. This is where all three of those lines are going to intersect. And that specific point that I'm looking at is called the circumcenter. Another thing that you will need to know out of this is that the circumcenter is equidistant from the vertices of the triangle. This is an extremely important part that you need to also get down. Okay, so we're going to form perpendicular bisectors in a triangle, and when we do that, it's going to form the point of concurrency called the circumcenter, which we know is equidistant to the vertices of the triangle. So, an idea as to what this looks like. Okay, I got my triangle here. Okay, what is a perpendicular bisector? We already talked about that. It's going to cross that, it's going to bisect a segment, and it's going to form a right angle. So, there's kind of the answer to it. And I'm going to draw in our first perpendicular bisector, which looks like that. And you can see that it crosses at a perpendicular or a right angle and splits that segment in half. If I draw in the second one, you can already start to see that my lines are starting to intersect. I have to draw in one more though. And there you can see that all three lines do intersect at the same point. That's our point of concurrency, which we're talking about. That point of concurrency, we're going to name it G. And that one, which we just talked about, is the circumcenter. Okay? That's circumcenter. And, again, that most important part that we need to know about the circumcenter is that it is equidistant to the vertices. My vertices of my triangle are A, B, and C. So, for example, GA here should be equal to GC and GB. Put in the distances there, and voila, you can see the purple ones. Okay, that's what we're talking about. The distances will be the same from that circumcenter to the vertices. Okay? The reason that we call this the point, the circumcenter, is because we can draw a circle with the center G, and all of those purple segments in there, those are considered a radius of the circle. So my circle is actually going to go around the triangle, like so. That's how they come up with the name of it. You don't necessarily need to know the circle portion as much, but you do need to know that the circumcenter is equidistant to the vertices. Okay? As an example, what I'm looking for out of this, it's going to tell you point P is the circumcenter of triangle ABC, and I need you to list any segments that are congruent. There could be more than one. Okay, so we need to think. The circumcenter is formed by the perpendicular bisectors. I'll write that down. Perpendicular bisectors. And it is equidistant to the vertices. Those are two important things that we need to know as soon as we see the idea of a circumcenter. Alright, so let's look here. BR. I want to find BR. It wants me to find a segment that is congruent to this one right here. Well, I know that point P here is kind of far off, but point P is this one. Here's my circumcenter. We know that the circumcenter is formed by perpendicular bisectors. So therefore, the segment that has to be congruent to it has to be this one right here, AR, because it has to split AR, because it has to split that segment into two congruent segments. Number 8 is going to be similar. Okay, if I'm talking about CS, the one that should be congruent to it should be then AS. Same idea, we're dealing with perpendicular bisectors. And finally, BP. I'm going to erase the rest of this stuff. BP is right here. Notice we're going from my circumcenter to the vertices. We're using this bottom portion. We are equidistant to the vertices of a triangle. So, I'm looking for point P out to each point on the triangle where my angles are formed. So, for example, BP should be congruent to PA and PC. We'll write both of those down as well. PA and PC are going to be congruent to it.